Formerly, when one worked alone, at a given point a decision was made, and one went in one direction rather than another, whereas in the case of working with another person and with computer facilities, the need to work as though decisions were scarce, as though you had to limit yourself to one idea, is no longer pressing. It's a change from the influences of scarcity or economy to the influences of abundance and, I'd be willing to say, waste. This quotation from John Cage perfectly summarizes for me the advantages and the attractions of algorithmic composition. Usually, composers working with a pencil and paper would decide on an idea and follow it through to the end in a very laborious process. If you encapsulate your idea in a piece of software, you can tweak that idea, tweak the software, work with the various parameters that the software uses to generate the music, and generate various different versions of your piece, all expressing your original idea, but with slightly different outcomes. And then you can select the best version of the piece that suits your needs and your goals to the best. So this refers back to John Cage's very perspicacious comment that working with computer facilities, we now have an abundance of material at our fingertips, and waste is going to be a natural byproduct of that. Why algorithms? As your old maths teacher said about numbers, algorithms are nothing to be scared of. Following Descartes' principle of solving difficult problems by dividing them into small and more manageable ones, an algorithm is merely a step-by-step procedure aimed at solving a particular problem. The gap between imagining a new piece of music and realizing it in score or any other format is often bridged by composers in an algorithmic manner, whether they do so explicitly or not. Algorithmic composition formalizes this process and makes it explicit. It usually involves the use of a finite set of step-by-step procedures, most often encapsulated in software routines to create music. The formalization of musical composition is nothing new. Bach's fugues can be analyzed in terms of their algorithmic properties. Going further back to around 1026, Guido d'Arezzo, the inventor of modern staff notation, developed a formal technique to set a text to music. In his case, a pitch was assigned to each vowel so that the melody varied according to the vowels in the text. But the beginnings of algorithmic composition can be traced even further back to the ancient Greeks and the Jewish Kabbalah. So what would be the motivation to make music algorithmically? Well, besides the advantages I explained at the beginning with regards to generating and regenerating pieces with slightly different material, the explanation lies at least partly in the cognitive processes involved in experiencing music. As we listen, we are not merely enjoying the sensual sonic experience of the moment, but setting up expectations of what is to come based on what has already occurred, not only in the music we are listening to, but in other pieces we know that are similar to it, as well as in all the music we have heard thus far in our lives. Essentially then, using our memory and predictive faculties, we listeners create musical architecture in our brains, and the more actively we listen, the more elaborate that architecture becomes. For centuries then, composers have taken advantage of this ability to build sonic structural relationships in time in order to formalize the compositional process. Formal planning cannot be conflated with algorithmic techniques, of course, but that the former should lead to the latter was a historical inevitability. There are many riches to be mined in algorithmic composition as, amongst other benefits, the expression of compositional ideas in software often leads to unexpected and exciting results, and these can seldom be achieved via traditional means. Algorithmic composition techniques can thus play an energizing role in the development of modern music across all genres and styles. Slippery Chicken is an open-source, specialized algorithmic composition program written in the general programming language Common Lisp and its object-oriented extension, the Common Lisp Object System. It has been in development since 2000. By specialized as opposed to generalized, I mean that the software was originally tailor-made to encapsulate my own personal compositional techniques and to suit my own compositional needs and goals. As the software is developed, however, many general-purpose algorithmic composition tools have been programmed that should be useful to a range of composers. The system does not produce music of any particular aesthetic or style, For example, although it wasn't programmed to generate tonal music, the system is quite capable of producing it. Furthermore, the software's release as open-source, object-oriented Common Lisp code encourages further development and extensions on the part of the user. The algorithmic composition system in Slippery Chicken has been used to create musical structure for pieces since its inception, and for several years now has been at the stage where it can generate, in one pass, complete musical scores. It can also, with the same data used to generate those scores, write sound files using samples or MIDI file realizations of the instrumental score. Techniques for the innovative combination of rhythm and pitch data are offered by Slippery Chicken, and these are arguably some of the most difficult aspects of making convincing musical algorithms. The project's main aim is to facilitate a melding of electronic and instrumental sound worlds, not just at the sonic, but also at the structural level. Now we'll finish this introduction with a short example made with Slippery Chicken by the composer Sean Reed and modelled on some of the musical processes developed by the composer Steve Reich.